Alright, welcome to section 1.7, absolute value equations and inequalities. And note, we are not covering objective 7. So here's a question. What does the absolute value represent? Well, I mentioned it previously in other videos, but the absolute value of a number is just talking about the distance from 0. Okay, so if this is talking about the absolute value of 5, it's just asking you how far that number is from 0. So that would just be 1, 2, 3, 4, 5, a unit of 5. Same thing if we had negative 5. That's just asking how far negative 5 is from 0, which is 1, 2, 3, 4, 5 units away, which is why the absolute value is always positive. Okay, so solving absolute value inequalities, we have a few different cases on what they look like. If we have the absolute value of a is equal to some number n, then we can split it into two options. We have the absolute value of a, when we're rewriting the absolute values, we want to rewrite it so we no longer have the absolute values. Okay, so the translation step, you should always have no absolute values anymore. So if a is equal to n, or a is equal to the opposite of n. Okay, that's if you just have the equal sign. That is how you translate it without the absolute value. So notice we don't have any more absolute values on this end. That is our goal. So we have another option. We have the absolute value of a is less than n. Now how would we rewrite that without the absolute values? Well, we're going to end up with opposite of n is less than a, which is less than n. Okay, and notice this goes for less than or equal to as well. And we have one more option of getting rid of the absolute values. If we have the absolute value of a is greater than n, to translate that without the absolute values, will be a is greater than n, or a is less than the opposite of n. Okay, so notice that change. We swapped the sign, and we swapped that sign. So we swapped the inequality sign and the actual sign of the number. Okay, so these are the three ways that we can translate and get rid of absolute values to continue solving. Definitely worth and should be memorized. Alright, so example 1. Solve the following absolute value equation. First off, is it an absolute value equation? The answer is yes, we have absolute values. And then, what sign does it have? Well, it has an equal sign. These ones are usually a little simpler to solve. And one other thing to note is that the absolute value is entirely by itself, which we want in order to solve. So let's go ahead and simplify that. We'll have 3x minus 4 is equal to 11, or 3x minus 4 is equal to the opposite of 11. And now we continue to solve. Okay, so that was the hard part, just going from the absolute values to no absolute values. And other than that, it's just normal solving, which we've done before. Okay, and then dividing by 3, x is equal to 5, and x is equal to negative 7 over 3. Oops, skipped a step. Divide by 3 there. Okay, and there we go. We just have our answers. Don't have any intervals or anything. We just have straight two specific numbers. Now let's take a look at example 2. This says solve the following absolute value inequalities. Ooh, graph the solution and enter an interval notation. Okay, so in this case, it's an absolute value, but we have an inequality symbol. So that changes the way we answer a bit. Now, way to memorize how I should split this up. I use goal. If my absolute value is less than, I'll break it into an and statement. Okay, so less than should be an and statement, which I did here. Less than, it turned into an and statement. If my absolute value is greater than, I'll go ahead and turn it into an or statement. So my absolute value is greater than, I'll turn it into an or statement. Just a way of memorizing it. So right now, my absolute value is greater than, which means I'm going to go ahead and split it into an or statement. Alright, so that means I have, dropping the absolute values, 4x minus 1 is greater than 11, or, please write the or, that is very important, 4x minus 1 is less than the opposite of 11. So please note the switch, less than, and then you take the opposite of that value. Okay, so solving, add 1 to both sides, 4x is greater than 12, dividing both sides by 4, we get x is greater than 3. Or, adding 1 to both sides, we get 4x is less than negative 10. And dividing both sides by 4, we get x is less than, well, negative 10 divided by 4, I can simplify that into 5 over 2. We get negative 5 over 2. Alright, but we're told to also graph our solution and answer in interval notation, so let's take a look at this. We have 0, we got the negative 5 over 2 here, and then the 3 over here. So let's say we want x to be greater than 3, but not equal to, and then x to be less than 5 over 2 and not equal to. And this is an OR statement, so because it's OR, we can still find the answer to this in interval notation. Starting from here and going to the negative 5 over 2, that's negative infinity all the way up to negative 5 over 2, but the bubble's not filled in, parentheses. And then union, here and on, so that'll be 3 to positive infinity. Once again, always use parentheses with infinity. And box your answers. Now let's take a look at example B. Alright, so you might be tempted to try and go ahead and split this. But remember, all of the formulas we had for getting rid of absolute values, our absolute value had to be by itself. And the problem B, it is not by itself yet. That is a problem. It needs to be by itself. We have this little plus 5 we got to get rid of. Let's go ahead and get rid of that. Subtract 5 from both sides. Then we have x plus 3 less than or equal to, and 7. Okay, now we have the absolute value by itself. Now we can split it. Well, that is a less than statement, or absolute value is less than. So looking at goal, less than refers to an AND statement. So we'll split this into negative 7 less than or equal to x plus 3 less than or equal to 7. So notice kind of what happens. You copy paste this without the absolute value, and then you just take the opposite of your end term and put it right there. Let me go ahead and rewrite that over here so I have more space. So negative 7 less than or equal to x plus 3 less than or equal to 7. Okay, to solve for x, we want to get it by itself, so we'll subtract 3. Remember, we have to do that to all 3 sides. And we end up with negative 10 less than or equal to x less than or equal to 4. Okay, well that is solved. That's our AND statement. Let's go ahead and graph that and then answer in interval notation. And there we go, in between, and then interval notation. We'll start at negative 10, and then we go until we stop at 4, and that is it. We include negative 10 and 4, so we'll go ahead and use the braces, and there we go. Now let's take a look at C, example C. Once again, the absolute value is not by itself, so we need to get it by itself. We'll go ahead and subtract 6 from both sides. The absolute value of 5x minus 3 is less than negative 2. Oh, you might be tempted to keep solving this with a less than, but just take a look at this. We have an absolute value which is always positive, and yet somehow it's supposed to be less than a negative 2. This is not possible. There's no solution. Okay, so this is one of those weird cases where there is no solution. We cannot have an absolute value less than a negative number. Alright, so D, let's take a look at D. This is asking 7x minus 3, when is that equal to 0? Well, this is one of those special cases. Because it's equal to, if we tried to split it using the regular equal method, it'd be 7x minus 3 equal to 0, or 7x minus 3 equal to the opposite of 0, which would still actually be 0. So we just have to solve it once, equal to 0 because this is the weird special case of being equal to 0. So solving, we get plus 3, 7x equals 3, and divide by 7 to get rid of that 7 by the x equals 3 over 7. And since it's equal to, we don't need an interval, so we do not need to graph because of that equal sign. So no interval notation and no graphing. And let's take a look at example E. Okay, this one is really weird. Why is it weird? Because we have two absolute values on either side. How would we solve this? Well, the way to do it is to basically drop the absolute values on one and then continue working with it that way. So let's go ahead and rewrite this, pretending that this one had the absolute value. So we'll get 3x minus 4 equals 5x plus 12, or 3x minus 4 is equal to, and the opposite of the other one, opposite of 5x plus 12. Now you could split it the exact opposite way and you'd still get the same answer. So let's go ahead and solve. I'll go ahead and get 3x to that side because I want my x's on one side. And we'll go ahead, oops, that should be a 12, minus 12 from both sides. End up with negative 16 equal to 2x, and dividing both sides by 2 to get x by itself, we'll end up with negative 8 equals x. Alright, so we solved that one. We don't need to do an interval because it's an equal sign, not an interval. And let's go ahead and solve the other side. We'll distribute that negative first, and then we get 3x minus 4 is equal to negative 5x minus 12. I'll go ahead and add 5 to both sides. Recall, I usually decide which side to put my variable on because I want it to be positive. So 3 plus 5x is 8x, minus 4 equals negative 12. We'll go ahead and add 4 to both sides, and I'll end up with 8x equals negative 12 plus 4 would be, let's see, 6, 8. We get negative 8, and then dividing both sides by 8 to get that x by itself, we'll end up with x is equal to negative 1. Alright, and that is it for this section. If you have any questions, once again, email me or visit me in my office hours on Wednesdays.